Now we're on the back, and you have to make decisions. Am I going to use the formulas like this, or am I going to try and do factor by grouping? And I hope that what you guys see is when you're using one versus the other, it's kind of obvious. Like if you have a bunch of middle terms like this, then these are not going to apply. But if it's just like kicking off with the huge x cubed or x to whatever crazy power, and there's one other term, these are probably in play. This first one, though, it is kind of weird. Like I can't really multiply a number by itself 3 times to get 3. And I certainly can't multiply a number by itself 3 times to get 24. Like 2 times 2 times 2 is 8. That's not nearly big enough. And then 4 times 4 is 16 times 4 is 64 is way too big. So it seems like we're kind of stuck, except that 3 and 24, that 3 is a common factor. So step 1 would be to factor out that common factor of 3, leaving us with an x cubed minus an 8, right? You can check. This is 3x cubed. This is negative 24 if you distribute. And yeah, I can think of something that multiplies by itself 3 times to make x cubed. That's going to just be little old x. And then if I want something that multiplies by itself 3 times or cubes to get 8, that'll be 2. And now that I know what these guys are, I know that for this pattern to work, whatever's here, I'm going to square it. That goes here. This middle guy is the product of these two things with the sign flipped. So these multiply to make negative 2x. I'll put a positive 2x here. And then this guy is going to be positive 4. Now, you should never take my word for it. You know, if this is bothering you, if you're like, why are you doing those patterns, blah, 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 then here's what you need to do to convince yourself. Take this x right here and multiply it by each of these terms. Take this negative 2 and multiply it by each of these terms, combine like terms. And you will see every single time you'll get an x cubed, you'll get some x squared terms, but they'll cancel. You'll get some x terms, but they'll cancel, and you'll get a negative 8. So if this pattern's bugging you, and it's making you uncomfortable, take the 1.5 minutes it takes to multiply it out and see that this does in fact multiply out to make this, because this pattern is holding, and this pattern is holding. Now for the next problem, we got all these crazy middle terms going on. So like honestly, obviously if we have an x cubed, that's a problem, but there's a lot of other stuff going on too, so we're going to start this off by breaking it into groups of 2. And I'm going to look at each group of 2 and think of a common factor. So for this guy, the common factor between the coefficients is 3. And of course I can take an x squared from both, leaving me with, well, if I wanted to get a 3x cubed and I had a 3x squared, I would need an additional x. If I had a 3x squared and I want to multiply to make 12x squared, I just need to include a 4. So that's cool. And then for the next guy, I noticed that it leads to a negative, so I'll definitely at the very least factor out a negative, but I also notice there's a common factor of 5. What would I multiply negative 5 by to get negative 5x? Well, I would need an x. And if I wanted to get a negative 20, and I had a negative 5 out here, I need a positive 4. And yay, 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 these are identical. And when they're identical, they become a common factor that floats out in front, and the other parentheses is filled with whatever was left behind. This is my final answer. And again, if this bothers you, if you don't like this, and you're like, this is uncomfortable, I can do it, but I don't get it, take a minute. Take x times 3x squared. Take x times negative 5. Take 4 times 3x squared takes 4 times negative 5. Do all that stuff, and you will see that you get this exact same polynomial back. It's pretty fun. Challenge yourself. Yeah, do that.